All right, welcome back, everyone. So today we are going to go through worksheet number 4. All right, and for worksheet number 4, as you can see from the success criteria, is going to be about your vernier caliper. All right, vernier caliper. So let's get started. Now, first off, on the parts of the vernier caliper, all right, I'm just going to scroll down to the answer for you guys to just pause the video and double check your answers itself. All right. Now, in general, the most important parts of your vernier caliper for measurement, when you're taking the measurement itself, would be number 1, your inner jaw, number 2, your outside jaw, number 3, your tail. Because these 3 allows us to measure different parts or different types of object. All right, so your inner jaw is actually here. This is your inner jaw. So, for example, you're measuring the inner diameter of a container that looks like this. As an example. So this is how we actually put the inner jaw to use. All right. Okay. The outer jaw, which is this one over here, B, it is used to measure your outer diameter. So for example, I want to measure the size of the outer diameter of a ping pong ball. All right. So this is how we clamp it in between the outer jaw. And the tail itself allows you to measure the depth of a hole or an object. So for example, if let's say I want to measure the depth, how deep a test tube is, all right? So I can put the test tube over here as an example. So this is a test tube, all right, as an example. So that's how it will look like. Or you can actually insert it into, say, you find a hole in the ground, or you want to measure how long your nail needs to be, so that you're using the right nail for the hole that you're trying to view or whatsoever. So that is how you use the tail of a micrometer. Now, when it comes to reading the micrometer, on the other hand, all right, the important parts would be this one, the main scale, as well as this one, the vernier scale. All right, number 1 and number 2. So they will combine together to give you the reading of the vernier caliper. All right, and in this case, the main scale is actually a longer one. So this is number 1. This is a main scale. All right, and this is number 2. This is your vernier scale. All right. So these two are important because you need to know how to read them. You need to know how to read your vernier caliper. It's not exactly the same as reading off a ruler, for example. All right. So now moving on. So this is how we actually read a vernier caliper. I'll be making use of these examples to show you the reading of the vernier caliper itself. All right. So for 2A as an example. So okay, let's take a look at this picture first. This one over here. All right. This one over here. Now, so usually when we are reading a vernier caliper, what we need to know is we always take a look at the 0 on the vernier scale. All right, so look out for the 0 on the vernier scale. So this is 5, all right, 4, 3, 2, 1. And so this line is 0 line. All right, 0 line. Always double check that it's a 0 line because sometimes in exams, the invigilators have been known to set an additional box just to confuse you. All right, so just take note that it is correct. Okay, so let me just erase away all of these additional lines so that I can start my example. All right, so find out where's the 0 on your vernier scale. So in this case, this is my 0. All right, look up. Is it in line with anything? Now, if it's not, all right, then we take the reading to the left of it. So in this case, this is the reading to the left of it. All right, now, but what is that reading? Okay, if you actually take a look at the first picture, right, you'll notice that the main scale is usually calibrated in such a way. So this is 0, all right, and this is 1. So what are all these lines? Logically, it should be 0 0.1, 0 0.2, 0 0.3, 0 0.4, 0 0.5, and so on. All right. So we apply that same understanding to the second picture. If this is 7, this will be 6.9, 6.8, 6.7, and the line that we want should be 6.6. All right. So that gives us a main scale reading of 6.6. Your main scale will give you up to the first decimal place. All right. Will give you up to the first decimal place. Then after that, once you have gotten 6.6, let's look for the next one, which is the line, the one line that forms a complete straight line between your vernier scale and your main scale. And in this case, the line that forms a complete straight line is actually this one over here, if you notice that. All right, look through all of the 10 different lines on your vernier scale. You notice that the one that's actually a straight line would be this one, which is 1, 2, and 3. So it's number 3. Now, we took one reading from your main scale, so it's only fair for us to take one reading from your vernier scale. Your vernier scale will provide the second decimal place. So your vernier scale will always provide the second decimal place. So it's 0.03. All right. And you add it up together and you should get a total answer of 6.63 as shown over here. So this is 6.63. All right. Now, but however, as you've been doing your self-study, I'm sure you also realize that sometimes your vernier caliper has got 0 errors. And that is like, for example, when you are, to give you guys a better understanding of 0 error, right? 0 error is basically like, let's say, for instance, you are trying to measure your weight. And before you step onto the scale, by right, it should be pointing at 0 because nobody's standing on the scale right now. All right, it should be pointing at 0. But let's just say one day you go back home and you want to measure your weight, but you realize that there's something wrong with your weighing machine. Instead of pointing at 0, what happens is that you realize it is pointing at maybe say a value of 1. All right. So that means nobody is standing on it, but it's actually 1 kg. All right. And this is what we mean by 0 error. All right. That means it's supposed to be 0, but it's not. So it's a 0 error. Let's say this weighing machine has a measurement of 1 kg. Right? If I step on it and my weight is, let's say, 51 kg. So by right, I'm sure logically all of us will know that the actual weight is 50 kg. All right, you take your actual reading and you minus away the 0 error. And that concept is actually very similar to what we are seeing over here. Right? So as an example, over here, you have got the following. All right, so this is, let's take a look. So this diagram, the first diagram shows you the 0 error. All right, and let's find out what is the 0 error. Read it normally. All right, so in this case, this is a 0 line. All right, look up. It is not in line with anything. So I take the reading to my left. The main scale is 0.0 plus the vernier scale. The one that is exactly in line is this one over here, which is number 2. So the vernier scale will be 0.02. And that gives me a zero error of 0.02 cm. All right. Now, so this is a positive 0 error. Positive 0 error means that, and it's important to write the plus. Positive 0 error means that you're not measuring anything, but yet there is a positive reading already. All right, so that's why it's called a positive 0 error. And as with the example that I was giving you about a weighing machine, right, we'll always take this is your actual reading. We'll always take the actual reading, and we'll always minus, this is your 0 error. All right, and you will get then the corrected reading. Now, as mentioned, it is very important for you to write down the positive sign, all right, because that will actually affect the value, as you can see later. All right. Now, for example, 2b, right, the first diagram actually shows you something very interesting. Now, let's take a look at this diagram. This is again a diagram for 0 error. So let me just label it here first. This is a diagram for 0 error. And if I were to look at it, right, so this is my 0 line. I look up, hey, it's not in line with anything. I take the reading to the left. Oh no, I'm in trouble. There's no readings to the left. Now, in this kind of situation, when you run into this kind of problem, it is actually known as a negative 0 error. Negative 0 error, right? Negative 0 error. So for negative 0 error, you have to do something very special. For negative 0 error, you always read in the opposite direction. All right, read in the opposite direction. Okay, so as an example, going back to the weighing machine analogy, right? Imagine that your weighing machine usually looks like this. So as an example, let me just draw it bigger this time around. So by right is 0, this is 1, and this is 99. So a weighing machine can measure up to 99. All right. And so one day you go back home, and instead of seeing this in your weighing machine, all right, what you see is you see something like this. All right. So this is 99, this is 0, and it's pointing over here. This is 98. All right. It's kind of illogical to know that, to think that your weighing machine will have a 0 error of 99 kgs. That's kind of unlikely. So in this case, we know there is a negative 0 error. All right. Okay. And in this case, the negative 0 error is actually negative 1 kg. So for the same reason, if I step on with a weight of 31, it shows me a reading of 31 kg. So in this case, I know that I should actually compensate for the 0 error by taking 31 kg minus the negative 1. That's my 0 error, negative 1. And you realize that minus and minus will give you plus. So it will naturally give you 31 plus 1, which is 32 kg. And that's your actual reading. All right. So same thing coming back to this. All right. Coming back to this, our negative zero error for our vernier caliper should have the same idea. So we have to count in the opposite direction like what we saw for the weighing machine just now. So look for the one that's in line. And the one that's actually in a straight line is actually this one over here. This line over here. So usually what we'll say is 5, 6, 7 is actually the number 7th line. But in this case, then it will be wrong because it's a negative zero error. You need to read it in the opposite direction. So for opposite direction, right, then it should be, this will be 0, this will be 10. So 0, 1, 2, 3. So this is our line. So our negative zero error, as you can see over here, is negative 0.03. All right. Reading the normal reading, only for the zero error, you read it in the opposite direction. After that, even though it's the same vernier caliper with a negative zero error, but when you use it to measure things, you read it normally. So in this case, I'm using the same vernier caliper with the negative zero error, but I'm just going to read it normally. This is the 0 line. It is not in line with anything, so I take the reading to my left. So my main scale is 5.9, as you can see over here. All right, my main scale is 5.9. And my vernier scale is the one that's in line. This one, it seems. It's number 9. So I just add it up. So you get 5.9 plus 0.09 to give you 5.99. All right. So again, for normal readings, we always read normally. All right. Okay. And then after that, same thing. Actual reading minus 0 error to give you the answer itself. All right. So actual reading minus 0 error will give you your corrected reading. All right. Okay. All right, again, if you are not very clear about the explanation, please feel free to contact your physics teachers. All right. But moving on, so these are the answer for part C. If you need to pause the video at any point in time, you need to replay the video at any point in time, please go ahead. All right. And of course, this is the steps to check for zero error, to make sure that our measurement is correct when we are using a pair of vernier calipers. So first thing is we want to check for zero error before even using the vernier caliper. All right. Always remember to do that. And secondly is to measure the diameters across different points of the coin. So what I mean is, for example, if this is my coin, all right, maybe the first measurement I do it this way. So this is number 1. All right. And then maybe the second measurement I do it this way. So this is number 2. All right. And perhaps measure it a third time, and this is number 3. And then after you find the average of these 3. All right. So this is to make sure that you get the correct reading. All right, that your reading is accurate. And also stating a source of error that might occur when using the vernier caliper. If you do not know the exact center of the circle, so for example, if let's say this is the circle that I'm trying to measure, and this is the center, but if we don't know the center, all right, if we don't know the center, and we use our vernier caliper, we might be measuring, say, somewhere around here, which we think is approximate enough, all right? But by right, if you know that the position of the center is actually over here, you realize that, no, what you're measuring is not the diameter, all right? What you're measuring is not the diameter, because the correct diameter should actually be from here all the way to here, from one end to the other end, all right, and passing through the center. So this is one possible source of error, all right? And with that, we are done with worksheet number 4, all right? Okay, I hope this video has been helpful to you, all right? So thank you, and I will see you guys in worksheet number 5.